Hello class 7 students, welcome everyone. So from today onwards we are going to start our online classes. So in the offline classes we have studied the chapter about electric current and its effects, right? So in this chapter we have studied about electric current. Yes, we have studied about electric current. We have also studied about the symbols of electrical components, symbols of electrical components, right? Then we have studied about one of the effect of electric current, that is heating effect. Yes, heating effect we have studied, and under heating effect we have studied about electric iron. Yes, electric room heater. Then electric fuse we have studied. Okay, electric fuse. Then electric bulb. Okay, clear? But what is now a magnetic effect of electric current? This is another effect. Magnetic effect. Okay, magnetic effect of electric current. So we'll see this, we'll catch this. Okay, all of you can take out page number 167 of your book. We'll start with activity 14.5. So in this activity you have to take a matchbox, that is a tray of the matchbox. All of you have seen this tray of the matchbox, right? Where the matchsticks are kept, this tray you have to take. Okay, tray of the matchbox. So take the cardboard tray from inside a discarded matchbox, wrap an electric wire a few times around the cardboard tray. Okay, you have to take electric wire also and you have to wrap it around over this matchbox. Okay, matchbox tray. Place a small compass needle inside it. Now compass needle, what is compass needle actually? This compass needle is actually a magnetic compass. What is it? Magnetic compass. Okay, it is what? Magnetic compass. Now as you can see this is the magnetic compass. Okay, this is the magnetic compass, and this at the pivot a needle is there. This needle is called as compass needle. Okay, and it usually points in the north-south direction. As you can see over here, it usually points in the north-south direction. And the needle of the compass, this compass needle, is itself made up of a magnet. This compass needle is there. So this compass needle, or the needle of the magnetic compass, is itself made up of a magnet. Okay, clear? So you have to place a compass needle, that is magnetic compass, inside the tray of the matchbox. Clear? So now connect the free ends of this wire to an electric cell through a switch as shown in figure 14.17. Okay, so what you are asked to do? You are asked to connect the free ends of this wire with the cell. Okay, so this is shorter one is the negative terminal of the cell, and the longer one is the positive terminal of the cell. Okay, and you should connect a switch also and an electric bulb also along with this in this setup actually. Clear till here? Okay. Now note the direction in which the compass needle is pointing. As I said that the compass needle is usually pointing in the north-south direction. It usually points in the north-south direction. Okay. And if you have another compass needle, or if you have another magnetic compass, just you can do this thing, that you have to bring a bar magnet and place the bar magnet near to the compass needle. What you will see? You will see that the needle of the magnetic compass will undergo deflection. Okay, The needle of the magnetic compass will undergo what? It will undergo deflection. Why it will undergo deflection? Because the needle of the compass is itself a tiny magnet. Okay, needle of the magnetic compass is itself a tiny magnet. Okay, so it will undergo a deflection. Clear? The compass needle will undergo deflection. Now, while watching the compass needle carefully, move the switch to the on position. Remember, this switch should be off at the beginning. Okay, but as soon as you place the compass needle inside this, as you can see over here, there is a compass needle. Okay, in the book, in the picture of figure 14.17, as soon as you place the compass needle inside it, place the switch on. Okay, what do you observe? Does the compass needle deflect? Yes, the compass needle will again show deflection. So initially when the switch is open, that is when the switch is off, no current is flowing in the wire. Okay, no current is flowing in the wires when the switch is off. Okay, and the compass needle will point in the north-south direction only. It will point in the north-south direction only. Here. Just like this. The compass needle will point in the north-south direction when no current is flowing through the wire. Okay. That means when the switch is open, when the switch is off, no current is flowing in the wire. So when no current is flowing in the wire, then the needle of the compass is what? It will point in the north-south direction only. Okay. So you can look over here that just like this. Okay. The compass needle will get deflected. Okay. The compass needle will move. It will move from its original north-south direction. It will move like this. Okay. The compass needle deflects. Okay, when the current is flowing in the wire. Clear? When the current is flowing in the wire, the compass needle will show deflection. Clear? So, in this activity, we will find that when current is passing through the wire, then the needle of the compass is deflected. The needle of the compass will be deflected from its original north-south direction. Okay, and it will point in another direction. So why does the compass needle deflect? Why does the compass needle deflect? See, the compass needle will be deflected only when it is acted upon by another magnet. Okay, the compass needle will undergo deflection only when it is acted by another magnet or another magnetic field, you can say. So the deflection of compass needle here in this activity shows that current carrying wire placed above it is behaving like a magnet. This current carrying wire is behaving like a magnet. Okay, so it will produce magnetic field around it. If the switch is on, the current flows through the wire and it will behave like a magnet. It will behave like a magnet, remember. Okay, mark my words. It will behave like a magnet. What will behave like a magnet? The current carrying wire will behave like a magnet. Clear? Okay, so now what is written here, you see, move the switch back to the off position. If the switch is moved back to the off position, does the compass needle come back to its initial position? See, if we open the switch now again, or if we move the switch back to the off position, the current will again stop flowing. The current will stop flowing then. Okay, are you getting it? So we will find that the compass needle will move back to its original position again. So this shows that the electric current flowing in a wire stops, then the magnetism produced by it will disappear. Clear? You can refer to this picture again. See, this is a cell. Okay, there is a cell, positive and negative terminal. Okay, there is a cell, and there is a switch also which is open. Here is a magnetic compass. So initially when the switch is open, or initially when the switch is off, there is no current flowing in the wire. So here no current is flowing in the wire. So if no current is flowing in the wire, then the compass needle is in its usual north-south position. As you can see, the compass needle is in its north-south position. But when the switch is on, or when the switch is closed, when the switch is on or when the switch is closed, current will flow. Yes, current is flowing in the wire. So if current is flowing in the wire, the compass needle will get deflected, or the compass needle will move. Okay, the compass needle will move from its original north-south position if current is flowing in the wire. Again, if you switch it off, refer to this diagram again. Again, if you switch this off, what will happen? Again, no current will be flowing in the wire. The compass needle will again show no deflection. Okay, it will come back to its original position, that is north-south position. Clear? So let us come to our book again. That repeat the experiment a few times. What does the experiment indicate? See, we know that the needle of a compass is a tiny magnet, as I have already explained you in the beginning, that the needle of the magnetic compass is itself a tiny magnet, and it usually points in the what direction? North-south direction. The needle of the magnetic compass will point in the north-south direction. So when we bring a magnet close to it, okay, if we bring a magnet close to it, the needle will undergo deflection. The needle gets deflected. Now in this activity we have seen that, what we have seen in this activity, we have seen that, next page, the compass needle gets deflected when the current flows in a nearby wire. In a nearby wire, if current is flowing, then, and if you place a compass needle near to it, the compass needle will show deflection. So can you connect the two observations? Yes. When the current flows through a wire, it will behave like a magnet. So when the current flows through a wire, does the wire behave like a magnet? Yes. When the current flows through a wire, it will behave like a magnet. Okay. So this experiment or this effect was first studied by who? Hans Christian Ørsted. Okay, so he was the first scientist who noticed the deflection of the compass needle every time when the current was passed through the wire. Clear? So when electric current passes through a wire, it behaves like a magnet. So this effect is only called as what effect? Magnetic effect of electric current. Okay, when electric current passes through a wire, the current carrying wire behaves like a magnet. So this effect is called as magnetic effect of electric current. Okay, and this magnetic effect of electric current is used to make a large number of devices in our daily life, like say electric bells, electromagnets. Electromagnet is there in our syllabus, we'll study in the next day, and electric bell is there. Okay, electric bell, electromagnets, then say electric fans also, electric motors also, loudspeakers, toys, etc., etc. These are the devices which works on the principle of magnetic effect of electric current. So in fact, an electric current can be used to make magnets. Do you find it too surprising? Let us try it out. We'll study about electromagnet in the next day. Clear? So this is all about magnetic effect of electric current. You have understood the effect? Okay. When electric current flows through a wire, and if a magnetic compass is placed near to it, the magnetic compass will show deflection. Okay, it will move. The magnetic compass will move. Why it will move? Because the magnetic compass is itself a tiny magnet. Okay, so we can conclude that the current carrying wire behaves like a magnet. Okay, clear? So yes, that's all for today. Thank you and have a nice day. We'll continue the chapter in the next day.